네, 이번 발표는 SKALE Labs의 바이스 프레지던트이자 Solutions Engineering인 크리스틴 페리님께서 Making dApps Feel Like Apps Using Elastic Sidechains to Run Smart Contracts and Store Data라는 주제로 진행해 주시겠습니다. 뎁 개발에 대해서 힌트를 얻으실 수 있을 것 같습니다. 네, 그럼 큰 박수 부탁드리겠습니다.
All right. Hello, everyone. Let's give this a try. Anya aseyo. Haza. Haza. I got it right. So the reason I opened with those two words is because, one, those were the two phrases that Erica taught me, and she successfully taught me how to say those. So hoping I got the pronunciation right, what I was trying to say to you was, hello, let's go in Korean. Now, I'm here to talk to you about scaling Ethereum. Basically, we're trying to make decentralized applications feel more like applications. And the best way that we found to do that is through using layer 2 solutions like elastic sidechains. So let's jump right into the problem. And we're going to do things a little bit differently because it's going to be half a presentation and half a demo showing you the pain points and actually showing you a possible solution. But the scalability problem is something that I'm sure all of us have probably seen when interacting with the blockchain. We get really excited about using the blockchain and the possibilities, and it seems like a game changer. But the moment you try to send any transaction, the first thing you realize is that it's slow and it's costly. So that's the scalability problem that layer 2 solutions that build side channels and plasma and sidechains are trying to solve. So that two-part issue, transaction costs and storage costs, is something that's very prevalent today. So on average, it's about 10 cents USD or more to send a transaction, and 10 cents USD or more to store 256 bytes of data. If that's not bad enough, speed is also an issue. So when you're looking to run transactions or store things on the blockchain, you immediately realize that you have to wait quite a long while before you actually get a response back. And it's crazy to think that that's the best we can do. So what are some of the solutions? Well, some of the solutions that we've seen used today, take CryptoKitties for example, is offloading computations to a centralized server. Well, we're here to kind of expand blockchain, and that feels as if it's kind of not staying true to the decentralization efforts that we're trying to push forward. Now, when it comes to storage, what are the solutions there? Well, we have IPFS or Filecoin, which is another tool you'll have to use to be able to store data directly on the blockchain. We can wait for ETH 2.0. This, I'm sure everyone is really excited about because it holds a lot of promises for speeding up and decreasing the cost of transactions on the blockchain. Or you can use a layer 2 solution such as SKALE and other layer 2 solutions out there that connect back to Ethereum. The goal with layer 2 that I want to make sure we drive home is that it's not looking to replace the layer 1 solutions. Instead, it's looking to complement it. Speed up the transactions, take the computation off of the mainnet, and place it in the area where it makes sense to run and have it run faster. So what does this look like? Well, the SKALE network, how does it work? Essentially, you're all familiar with Ethereum, where we have decentralized nodes that are operating to process transactions. Layer 2 solutions work in a very similar way. It's going to be a decentralized network, but the difference is instead of having one blockchain where you're sharing it with other dApps, what we do is we group together a small subset of those nodes to create a sidechain that's specifically dedicated to just your application. Now, what that means is that it runs faster. But we also add in layers of security through consensus to make sure that you don't have double spend or people are trying to steal your money that you are potentially storing on the sidechain as well. Now, to take this a bit further, when we have our sidechain, again, we're not looking to get rid of Ethereum. In fact, we're looking to complement it. So if we see this side by side, what you'll see is that if you wanted to use a sidechain, you could use the exact same tool set that you've already used for getting up and running with Ethereum. So that Web3 connector that you have going to Ethereum, you can send that to the SKALE network as well. Now, for developers in the room, how many developers do we have out here? Do we have any? There we go. 1 at least, 2, 3, 4. OK. So there's quite a few. Well, the idea here is that developers still want to be able to link back to the mainnet. And with a sidechain, we offer that capability. But when you want to deploy your smart contracts, again, that computation that you've written into code, you can speed it up by deploying those smart contracts directly to a sidechain. When you deploy it to a sidechain, what that means is that you're no longer restricted by the slowness and the transaction costs of Ethereum. In fact, on the sidechain for SKALE, what we have is a 0 gas cost for end users. Now, let's say that you're playing a game, rock, paper, scissors, and you're just making a move. You don't necessarily want to pay a gas fee for just selecting a move and playing the game. Maybe you want to pay a gas fee towards the end when you're looking to exit on the money you probably won from that game. Now, what that means, though, is that we're still going to need to link to the Ethereum in order to exit those tokens back to that end user. And with sidechain layer 2 solutions, we enhance the usability for users by making that bridge or protocol possible, where we're able to send tokens from the sidechain back to the Ethereum to release back to the end user. So again, I said I was going to do things a bit differently. I don't want to bore you completely with just slides, so we're going to do a bit of a demo. And while they're switching over that, let's bring it up over here. And let me show you what this looks like. So again, let's say that we have a dApp. It's connected to the Rinkeby network, as you can see that I have it connected to in MetaMask here. And we're going to play a game that is linked to a smart contract that I have deployed to Rinkeby. So anyone in the crowd want to play with me? Which move should we pick? Scissors? All right. Good move. So what you're seeing is a very familiar flow that users are faced with today. They have MetaMask downloaded, which is something they had to actively go and pursue. They're seeing a gas cost because they're paying for a transaction for just simply playing a game. And when I confirm that, we're now faced with the very similar dilemma of now we have to wait. So in my head, I'm saying, Haza, Haza, let's go, because this should really be a lot faster than it is right now. So we're going to wait a little bit longer, because it shouldn't take that much longer to process it on Rinkeby. But if I were a user using a normal application, this is not the experience that I would expect. I would expect to just see the transaction come back. So this is going to take a while. Now, there we go. You won. Congratulations. Let's see how we can speed this up using a layer 2 solution. Now, again, one of the things I want to drive home is that we see scalability as a usability problem as well at SKALE Labs. And so when it comes to usability for dApp developers, we also want to make sure that it's easy to get up and running for making a switch from Ethereum to a sidechain. So if we take a look at the documentation, I'm going to go to the Getting Started guides. We've simplified it to a 3-step process. But the main thing you need to know here is that, again, you can use the same tools, and the only thing that you have to switch is the endpoint that you are sending your smart contracts to. So we have a few developers in the room, so I'm going to show you what this looks like in code and go through that pretty quickly so we can bring it back to the real problem at hand, speeding this up. So to show you how simple it is to transition from Ethereum to a sidechain for faster processing time, I'm going to go ahead and copy the exact same configurations that I've used to deploy to Rinkeby and a local testnet. This is an endpoint that I have just for demo purposes. And I'm going to copy the exact same code that I used for deploying to Rinkeby. Make some small changes to now reference that SKALE endpoint, and that's it. Ease of use for the dApp developer, as you can see, there's not much hurdles that they have to go through in order to make a switch to get faster usability. Now, what does this look like as far as deploying? I'm going to go ahead and copy this out, and let's go ahead and deploy to Scale. So again, for those not familiar with Truffle, Truffle is an easy-to-use tool that allows developers to deploy their smart contracts to Ethereum, to any of the testnets. And you can also use that exact same tool to, again, use a layer 2 sidechain solution such as Scale. Now, one of the things that developers will probably see in the room is that this is running a lot faster than if you were deploying to Rinkeby. If I would deploy the same 3 smart contracts to Rinkeby, what that looks like is it takes at least 15 minutes for it to process. And what you just seen here is it processed in less than a minute. So I'm going to go ahead and restart my game. And let's go ahead and make some changes here to start to use that sidechain. So I'm going to come back here to rock, paper, scissors. In MetaMask, again, the end user is going to have to determine that they want to switch to a new network. And we're going to switch to that SKALE network. Now, let's try this again. Anybody else want to pick a new move? Rock? Rock? OK. Let's pick rock. Now, I want to make sure that you see a few different changes here. We're using SKALE, which means for the end user, for basic transactions, you don't need to charge gas. It just doesn't make sense. So instead, gas costs are free. Instead, what you're doing is we're taking it more like an AWS Amazon model. You rent space on the sidechain, and your end users are not restricted by having to incur the unnecessary costs for just running your dApp. So if I confirm this, one of the things we'll see is that, like before, I didn't have to fill time by trying to talk while Rinkeby was bringing back an actual result. Instead, what you saw is this dApp now feels like a normal application. So if I were to then develop my dApp using a sidechain, I can expect a very similar experience for my end users that they expect with using Facebook, using Amazon, using any other product out there today that is centralized. But let's take this a bit further, because I didn't want to just talk to you about scalability. I wanted to talk about usability. And when I think about usability, it means not creating friction for your end users. To me, having the user download another tool to use my dApp, such as MetaMask, that creates friction. If they don't know what a blockchain is, that creates friction. So how can we get around this? Well, when we're thinking about usability, we want to make sure that we're using the right tool set. So if I come back to the documentation, what we do is, at Scale Labs, if we really drive home that it's really beneficial to take advantage of API-based wallets. Now, I know that there are a few out there. I'm just going to use one for the sake of this demo, and we're just going to use Portis. Now, Portis has a really cool feature that's called Trust My App, which means that when I click on a basic transaction that doesn't have a cost, the user doesn't have to verify it. It simply goes through using their wallet because they determined that this app is safe. Now, similar to what I showed you with getting up and running with just using Scale, it's very similar here with Portis. If you want to integrate Scale with Portis, again, all you need to replace is that endpoint that you would receive from us. When you replace that endpoint, what this looks like in practice is now you can create a login button. A login button that has been brought into the application. It's not part of the browser. The user doesn't have to download anything. Instead, they can simply use your application without worrying about the fact that it's on a blockchain. So if I go and sign in here, what you'll see is Portis created a wallet for me, and they create an easy, normal authentication process of simply just an email and password. So it's making the user feel as if they're dealing with a normal application out there that's still decentralized. So let's go through and play this game again to see what that looks like. Now, one last time, anyone else want to pick a move? Paper? Perfect. OK. So remember how I said for zero-cost transactions, it doesn't make sense to have the user confirm that? Well, what you just saw is that by using an API-based wallet, the user didn't have to. Instead, I can simply play the game using the blockchain. And so usability has already gone through the roof by just making two simple changes within your application. One, using a layer 2 solution, and then two, using an API-based wallet. Now, one of the things I talked about was that on a layer 2 solution, it's not just about speeding up smart contracts, lowering costs, but also about modularity. Now, if you want to use another tool such as IPFS or Filecoin for storing data, you could, but what if that was all wrapped into the same tool, where in addition to deploying your smart contracts, you could also upload assets, files, maybe even your entire application written in front-end code, HTML and CSS. With SKALE, that's possible. So what that looks like here, again, bringing it back to the documentation, we've created a process where you would be able to upload, download, delete your files just as if you're dealing with a normal NPM package or library. So we've created these really easy to use tools or methods, and it's all open source. So it's not a black box. You have full control over making changes that need to meet the needs of your application. But again, getting up and running with SKALE, we're trying to make it not just easy for the end user, but usability to us also means making it really easy for the dApp developer. So let's see what this looks like in practice. Now, again, similar to the rock, paper, scissors game where I had a smart contract and I deployed it to RinkB and SKALE, with file storage, once you get a SKALE endpoint, you already have access to file storage. So you can start to upload your files just as if you're dealing with Amazon S3, where you can upload files and use it within your application. So this is connected to file storage, and I want to show you what this would look like. So let's say we wanted to host those images for rock, paper, scissors. I will be able to link in to that file storage, which is going to use that upload feature, upload all of those bytes, and save them onto my SKALE chain. Now, if you have a SKALE chain that has 16 or 32 nodes, what that means is that we're replicating that across all the different nodes within the network. Now, bear with me just a sec. So hopefully I still have this turned on, and looks like I'll need to restart it. And let's do this again. So while that's loading, let's show you what this looks like in code again. So similar to the endpoint, you won't have to do much to get up and running with file storage. Instead, all you have to do is pass your SKALE chain endpoint directly to the file storage client and just start using it within your application. So when we go back to our application here, and we decide to upload a file, what will happen is, again, it'll use our upload feature and upload it to our application, which means that we can then interact with it directly here within our app. And let's make sure it's working. All right, no luck today. We'll blame it on the internet. But that's what I wanted to talk to you about today, scalability and usability with SKALE. So if you're interested in trying out a SKALE chain, join our Discord. We'll give you a SKALE endpoint that you can play around with and start to test out within your applications that you're building. And if you want to learn more about any of our other features that we have, join us tomorrow. We're going to be doing a deeper dive into the product and into the tech, talking more about our consensus and validators process as well. So please join us. Thank you. And if you have any questions, let me know.